Swipe left, swipe left, swipe right. You know what Tinder reminds me of? Clean room-based advertising. Yeah, how'd you know? Cut. Look, no time for skits for this one. If the length of this video is an indication enough, we have a lot to go over when it comes to IAB Tech Lab's Open Private Join and Activation Specification. So let's just get into it. I don't even know what Open Private Join and Activation sounds like it could be. It's a supreme piece of jargon, but what IAB Tech Lab means for it to be is a way for advertisers and publishers to match their first-party datasets in order to target the overlapping audiences with ads, which sounds simple enough. Process for pulling it off, well, there are all these keys and level of encryption and something called a trusted execution environment that's really not much more than a super secure computer. But considering how valuable first-party data is becoming to the advertising industry and how challenging it can be to securely use that data to target ads, it's worth digging into the Open Private Join and Activation approach.
If I think about what's required in the industry right now, there is not a scalable RTB solution yet for utilizing PII in a privacy-safe way. Now, we've talked about the scalability and usability even of addressable media identifiers, what those match rates look like, and I think the industry has said we might need additional solutions. So there is a optionality that is created here to increase scale.
OPJA's whole reason for being is that advertisers and publishers are becoming more reliant on their first-party data because of the third-party cookie going away and privacy regulations getting stricter. So many are putting their audience datasets into data clean rooms. Problem is, those clean rooms don't make it super easy to use the data for ad targeting, particularly when an advertiser and a publisher are using different clean room providers.
When you look at what's still happening with clean rooms, there is a lack of interoperability. And so they're trying to create basically primitives in a protocol that the industry has to abide by or is governed by, because it's not a conversation of, I don't think, like a technical limitation. I think it's really more of a business conversation at this point of whether a lot of the retail media networks and walled gardens want to participate in more of this interoperable data sharing, data collaboration type of workflow.
And maybe the most important thing that it does is it allows people to take their clean room adoption to the next level. What you might find is your favorite publisher or publishers are not directly integrated with your clean room, right? So now you've got a problem of how do I now get that data into, whether it be a PMP or a programmatic deal of any sort. And ultimately what it does is it allows those companies to utilize the entirety of, or will hopefully utilize the entirety of their relationships to leverage their PII.
Cool, but how? Well, there are two main steps to the OPJA process. One, matching an advertiser's and a publisher's first-party audiences, aka finding the identifiers like email addresses that appear in both companies' datasets. And two, targeting ads to the overlapping audience members, aka passing the matches through the ad tech intermediaries involved in programmatic ad buying. Here's Bosko Milikic, who's one of the OPJA's authors, to explain.
There are really two major components to enabling activation use cases through clean rooms. One is matching itself. Obviously, if both parties are using the same clean room vendor, the answer to that is obvious. But if they're not, you need a way to do the matching that from a security standpoint is robust enough for all parties involved so that the parties can trust the protocol, basically that enables the matching to do so in a secure way that doesn't leak their data. The second component is how do you get information that is established during the matching process, like for example, whether a user record is in the match or not in the match. how do you get that information securely to the DSP, which is being used to decision on whether or not to serve an ad or bid on the opportunity to serve an ad?
So 2 questions there. How do you do the matching and how do you do the targeting? Let's start with the first. And for that, we've got to talk about keys because there are a lot of them involved. It's like everyone's a custodian. And these keys are kind of exactly like what they sound like. They're used to lock up data and then to unlock data, but they're not actual physical keys. This is an extremely basic analogy, but they're like code words used to translate secret languages. Like, you know how in Pig Latin you take a word, move its first letter to the end, and then add A? That code is the key. If you know the code, then you know that ode K is code in Pig Latin, which, ridiculous as it may sound, means that you were able to decrypt it. If you know how to turn a word like code into Pig Latin, then you know how to encrypt it. Now that we've got a handle on keys, we can get into how they're used to encrypt and decrypt data so that advertisers and publishers' data can get passed around and be matched without everyone in the programmatic supply chain getting a look at that data. And actually, OPJA has 2 options for how data can be matched: private site intersection and trusted execution environment. We'll break down how each method works, but at the most basic level, both methods use a 2-step encryption process. But private site intersection uses a process that basically runs the data through a very mathy Rube Goldberg machine. Meanwhile, the trusted execution environment basically uses Edward Snowden's computer to do the matching before it self-destructs Mission Impossible style. Okay, let's start with private site intersection. Step 1, the advertiser and publisher encrypt their respective datasets. Step 2, they exchange their encrypted datasets. Step 3, they each encrypt the other's datasets. Step 4, they pass the doubly encrypted datasets to what's called a matching server, which can be the cleanroom provider they've hired to handle their data. If the advertiser and publisher use different cleanroom providers, then they'd either need to pick one to be the matching server or bring in a third cleanroom provider to be the neutral server. Step 5, the matching server goes through the 2 doubly encrypted datasets to see which entries match. Here's where you may be thinking, well, gee, Tim, if the datasets are encrypted not once, but twice, then how the hell is the matching server able to see if someone's email address appears in both the advertisers and publishers' datasets? Well, it's not. Get ready, because here's where the keys come in. But in this case, it's better to think of the keys as numbers. So private site intersection uses what's called a commutative encryption process. Think of it like a math equation where the order of operations doesn't change the final result. As a super simple example, let's say the advertiser and publisher each have an ID for someone in their datasets that's the number 5. Typically, the ID would be a person's email address, but for our purposes here, a person's email address is 5. Just 5, not 5@gmail.com, just 5. Okay, and then the advertiser and publisher each have their secret keys that they use to encrypt the IDs, and the encryption process is just multiplying a given number to the power of the secret key number. So in this case, the advertiser multiplies the ID to the power of 2, and the publisher multiplies it to the power of 3. Then they exchange these encrypted IDs and use their secret keys to encrypt the other's entry, multiplying it by the power of 2 and 3 respectively. Now they send the doubly encrypted entries to the matching server, which is able to see, hey, they match, but isn't able to see all the math that made them match, and therefore isn't able to reverse the math to uncover the ID.
We actually don't want any party to learn who's in the overlap. So what we're doing is we're using this middleman server that receives the doubly encrypted data sets, does the comparison, and then is able to generate a label that indicates whether each individual record is or isn't in the intersection.
Thus the name private site intersection. Trusted execution environment is similarly on the nose with its name, which is annoying to say repeatedly, so I'm going to call it T from here on out, which rhymes with key, which is good because there are a lot of keys involved. So many keys. All right, so instead of the advertiser and publisher doing all the encrypting and no one doing any decrypting, the T method has what's effectively a super fancy walled-off computer doing the decrypting. This computer is the T, and it's run by the matching server, aka the cleanroom provider. That probably sounds like the matching server would be able to access the raw data decrypted by this computer, but it's not. Here's how it works, and here come the keys. Step 1, the T creates 3 sets of keys. We'll call these the data keys because they're only used to encrypt and decrypt the advertisers' and publishers' data. 1 set for the advertiser, 1 set for the publisher, and 1 set for the T. That last set of keys never leaves the T, and the same goes for a copy each of the advertiser and publisher keys. and each of these keys will be deleted and the T will be wiped once this matching process is over. This is a big reason why the T is supposed to be a secure method for matching the datasets. Step 2, the T needs to send the advertiser and publisher the respective data keys, but it can't just leave them like an unwrapped package on someone's doorstep. It needs to encrypt them first. So it uses a separate set of keys that the advertiser and publisher each have for the T to use to encrypt the data keys. Like I said, a lot of keys. Step 3, the T sends the advertisers and publishers data keys to the matching server, which cannot decrypt them because it would need the private set of keys that the advertiser and publisher keep tied around their neck, which is all I'm going to say about those private keys because, I mean, come on, so many keys. Step 4, the matching server sends the data keys to the advertiser and publisher, which decrypt them using those private keys I said I wouldn't talk about anymore. Step 5, the advertiser and publisher use their data keys to encrypt their first-party datasets and send them to the matching server, which doesn't have access to the data key locked up in the T and can't decrypt the datasets. Step 6, the matching server tags the encrypted data as belonging to either the publisher or advertiser and passes it to the T. Step 7, the T decrypts the advertisers and publishers' data using its copies of the respective data keys. Step 8, the T encrypts the advertisers and publishers' data using its own data key that never leaves the confines of the T. This way, if an ID appears in both datasets, then anyone looking at the encrypted IDs created using the T's data key will be able to see that they match but won't be able to decrypt them to see the raw IDs. Step 9, the T passes the advertisers and publishers' re-encrypted data back to the matching server to do the matching.
In the case of a trusted execution environment, the security model is different. There you have it's a hardware assisted approach. So there the parties are interacting with a server that runs on a special type of hardware, and that hardware enables the parties to trust that the server is running what it says it's running. And also it enables them to encrypt their data with keys that only this really special part of the server in hardware is able to decrypt. And they can do this in a way that they can independently verify by talking to the hardware that this is happening. And so as long as they trust the hardware to do what it says that it's doing, they're actually able to do this through a server operator where they might not even trust the server operator with their data. But because they have this ability to attest the hardware, they can have confidence that their data remains protected.
So we've covered the matching part of OPJA, aka the private join. Now we've got to go over the activation, or how the match data is made available for ad targeting. After the matching server has found the overlapping entries, regardless of whether it used the private set intersection method or the trusted execution environment method, it sends a list of the match results to the publisher. This list includes an ID for the entire match transaction, which is like a receipt saying these results correspond to a match made between this advertiser and this publisher using this matching server. It also includes a set of encrypted labels that will later be used to determine whether an ad impression corresponds with the matched ID, but right now it just looks like a bunch of nonsense. Labels look like nonsense because they were encrypted by the matching server using a set of keys that we'll talk about in a minute. Publisher combines this information with its original data set. That way, when the publisher has an ad impression to sell against someone in its data set, the bid request will include the match transaction ID and the encrypted label. Okay, now at some point, someone is going to have to decrypt that encrypted label to see whether the audience member on the other end of an impression is the matched user who appears in both the publisher's and advertiser's datasets. That someone doing the decrypting is called the ad activation system. This role can be performed by either the supply-side platform that the publisher uses to sell ads programmatically, or the demand-side platform that the advertiser uses to buy ads programmatically. Either way, the advertiser and publisher will have needed to decide on which to use before the matching process even started. And one reason for that is because the SSP or DSP will be given a set of keys, more keys, to decrypt the encrypted label and see whether an impression is associated with a matched user or not. What's important to call out is that the SSP or DSP will not be able to see the raw personally identifiable information for that user. That's not what's hidden in the encrypted label. Instead, decrypting the encrypted label will effectively just reveal match or no match. Another reason that the advertiser and publisher have to decide off the bat whether to use an SSP or DSP as the ad activation system is because that affects how the match is activated in the programmatic ad sales process. For starters, when the matching system is encrypting those encrypted labels used to communicate whether an impression is associated with a matched user or not, one of the keys it uses corresponds to the SSP or DSP chosen as the ad activation system. That's because the SSP or DSP has a private set of keys that will be needed in order to decrypt the encrypted label. The activation process also differs depending on whether the SSP or DSP is the chosen ad activation system. We'll start with the DSP process because it's somewhat simpler. Now, I didn't say simple. Nothing about OPJA is simple. But when we get to talking about the SSP process, you'll see why I said simpler. Okay, so if the ad activation system is the DSP, the advertiser receives information about the match transaction, including the match transaction ID and a set of keys that the matching server used to encrypt the label signaling a match or not. This way, when a bid request from a publisher makes it to the DSP is able to recognize the match transaction ID included in the bid request and decrypt the encrypted label to see whether the user on the other end of the impression is someone in the advertiser's first-party dataset and bid on the impression accordingly. If the ad activation system is the SSP, then the publisher receives the match transaction information. Publisher proceeds to create a private marketplace deal within the SSP and associates it with the match transaction by passing the match transaction ID and those keys the matching server used to encrypt the labels. Publisher also passes a corresponding deal ID to the advertiser. Now, when the advertiser wants to target its matched audience on the publisher's site, it has its DSP pass the deal ID to the SSP. The SSP sees this deal ID and asks the publisher for an ad impression to sell, also known as a bid request. Publisher sends a bid request containing the match transaction ID and encrypted label. The SSP then uses its keys to decrypt the encrypted label, and if the label is revealed to be a match, sells the impression to the advertiser. Like I mentioned, whether to choose the publisher's SSP or the advertiser's DSP to be that activation system is up to the publisher and advertiser. But there is one consideration that advertisers in particular should keep in mind when making that choice.
There are some important things to be aware of if you're doing activation in the SSP. We call them out in the proposal. In particular, what you need to be aware of are potential collusion scenarios. So if you have a scenario, for example, where the publisher and the SSP are the same entity, then doing the decisioning in the SSP leaks information on the match results to the publisher. So you need to be aware of that, because in those scenarios, the advertiser would want to insist that the labels are encrypted for their DSP so that the information's not available to the pub.
In case it's not obvious, there are way too many steps in the OPJA process to go through this each and every time an ad impression goes up for auction, especially considering that that would need to be done for each and every advertiser that a publisher wants to match its audience with. Instead, this matching would be done on an occasional basis, whether that's once a day, once a week, once a month, once a year, once every few years, is entirely up to the advertiser and publisher.
It really depends, on the particular situation and how static the data sets are, but absolutely, it's something that you should be able to repeat periodically.
And that is the open private join and activation process, which is kind of intense. And it kind of needs to be. Advertisers and publishers aren't wild about passing around their first-party data, but first-party data is becoming more important for identifying audiences when targeting ads. So OPJA needs to offer a way to thread that needle by providing a means of matching audiences while limiting the direct sharing of those audiences' personal information, which is where all those keys come in.
When I take a step back and I look at what we are asking from the buy side, we do not want to push first-party data through a privacy-safe API into a clean room environment so that the analysis can be done inside of a siloed box or clean room environment one by one. You need to adhere to certain tenets around data security, data governance, no movement of data, things like that. And I think that's what this particular working group is trying to do.
There's non-movement of data, and then there's pure non-movement of data, right? We're gonna see better scale of these solutions when we get to a level of pure non-movement. And this actually, the way that I've been kind of constructing pure non-movement in my brain and actually in practice, is a little bit like what OPJA is doing, because what they're really doing is they're saying like, look, we're going to create a new key, right? Like we don't want you to pass us the data. We want you to pass us a key. And in my mind, that goes a big, it takes a massive leap, you know, one step forward for the IAB, one giant leap for advertising et al. In the direction of pure non-data movement.